Hello and welcome back. In this video, I'm going to talk about Apache Kafka and how streaming is done using this powerful platform. This brief introduction to Apache Kafka is important to help you understand the basic concepts of this platform, and it will be beneficial for this project, especially if you are not familiar with it. First, let's understand what Apache Kafka is. Kafka is a distributed streaming platform designed to handle high-throughput, real-time data feeds. It was originally developed by LinkedIn and later open-sourced under the Apache Software Foundation. Kafka allows you to publish and subscribe to streams of records, much like a message queue or an enterprise messaging system. This capability is crucial for managing the flow of data in systems that require real-time processing and analysis. Moreover, Kafka provides fault tolerance, scalability, and durability. These features make it suitable for a wide range of use cases, including real-time analytics, log aggregation, and messaging. Its robustness and reliability ensure that it can handle large volume of data efficiently and effectively. In summary, Kafka is a versatile and powerful tool that plays a crucial role in the real-time data processing landscape. It helps businesses and developers manage data streams efficiently and reliably. Now, let's dive into the core concepts of Apache Kafka. First, we have topics. Kafka organizes data into topics, which are essentially feeds of messages, also known as events. Each topic is identified by a unique name, allowing producers and consumers to interact with the right data streams. Next are producers. These are applications that publish data to Kafka topics. Producers write data to topics, making it available for consumption by other applications or services. On the other side, we have consumers. Consumers are applications that subscribe to Kafka topics to process the data. They read messages from these topics and process them based on their specific requirement. Brokers play a crucial role in Kafka's architectures. Kafka operates as a cluster of servers known as brokers. These brokers are responsible for storing and managing the data, and they facilitate the communication between producers and consumers. When we talk about cluster in Kafka, we are referring to a group of data brokers working together. This cluster setup provides a distributed messaging and streaming platform, ensuring high availability and fault tolerance. Finally, we have Zookeeper. Zookeeper has traditionally been used to manage the Kafka cluster. They handle tasks such as maintaining configuration information, naming and synchronization, ensuring the cluster runs smoothly and efficiently. However, starting from the Apache Kafka 2.0, it is possible to work without Zookeeper and using alternative method to manage the Kafka cluster. For this project, we will be using Zookeeper. Understanding these core concepts is essential for effectively using Kafka in any project, as they form the backbone of its powerful streaming capability. Let's now discuss how Apache Kafka works. First, producers publish message to Kafka topics by sending records over the network to Kafka brokers. Producers are responsible for generating data and pushing it into the Kafka ecosystem. These messages are stored in an immutable append-only log structure called a partition. Partitions help Kafka manage and organize data efficiently, enabling to handle large volume of messages. Consumers subscribe to topics and read messages at their own pace. Each consumer maintains its own offset, which represents its position in the log. The offsets ensure that consumers can keep track of which messages have been read and processed, allowing them to resume from where they left off in case of failure. Kafka provides fault tolerance and scalability through replication and partitioning. Data is replicated across multiple brokers to ensure reliability and high availability. Additionally, topics can be divided into partitions, which allow Kafka to distribute the load and enable parallel processing, significantly improving process performance and throughput. Understanding this mechanism is crucial for leveraging Kafka's full potential in real-time data processing and ensuring robust and efficient data flow in your project. Before we wrap up, let's talk about key features. First, scalability. Kafka can scale horizontally by adding more brokers to the cluster. This capability allows Kafka to handle increasing data volumes and processing loads efficiently. As your data needs grow, Kafka can grow with them. Next is fault tolerance. Kafka ensures high availability and fault tolerance by replicating data across multiple brokers. If one broker fails, other brokers can take over and continue serving requests, ensuring that there is no data loss and that the system remains operational. Durability is another crucial feature. Messages in Kafka are persisted to disk, which means they are stored reliable and are not lost even in event of system failure. This durability ensures that your data is safe and can be retrieved whenever needed. Finally, Kafka supports real-time processing. Kafka enables real-time stream processing through frameworks like Kafka Streams and Apache Flink. This allows you to perform complex analytics and transformation on data as it streams through Kafka, providing timely insights and enabling responsive applications. These key features make Kafka an excellent choice for managing and processing large streams of data in a reliable, scalable, and efficient manner. Finally, let's talk about how to get started with Apache Kafka. First, to get started with Kafka, you can download it from the Apache Kafka website and follow the installation instructions. This will allow you to set up Kafka on your local machine or server. You can set up Kafka cluster with multiple brokers to experiment with distributed messaging and streaming. This setup will help you understand how Kafka manage data across different nodes and handle load distribution. Once your cluster is set up, you can create topics, produce messages, and consume messaging using Kafka command line stores or client library available in various programming languages. These tools and libraries make it easy to interact with Kafka and integrate it into your applications. Additionally, you can explore more advanced features of Kafka, such as stream processing and integration with other systems like Apache Spark and Apache Hadoop. These integrations can help you perform complex data processing and analytics on streaming data. In this course and next series courses, I will cover more of these points in more detail. I will guide you through the installation, setup, and usage of Kafka, and I will delve into advanced features to help you leverage Kafka's for potentials in your project. Thank you and see you in next videos.